This lesson is about rotations in geometry. So when we take an object and we rotate it around a particular fixed point. Now, most of the time what's going to happen is we're going to be rotating it about the origin or about the point 0, 0. So that's kind of what we're going to focus on with the lesson. A couple of things to highlight for you. First of all, notice the notation for how we rotate. We use a lowercase r, and then they're going to say how many degrees you rotate, and then if it's not around the origin, what point does it go around? Okay? This is another one of our rigid motions. Now, to truly understand the idea of rotations, we really focus on a couple of different things. First of all rotations are counterclockwise. Okay? Counterclockwise. So that means that we're kind of rotating the opposite direction that the second hand on a clock ticks. Okay? Another way to think about it is you're rotating to the left. Okay? So that's what counterclockwise means. Now, in order to understand how rotations work, the first thing I want to make sure that I recall is what do points look like that are in the coordinate plane? For example, I know up here in the first quadrant, points are both positive. All right, the x-coordinate and the y-coordinate are both positive. Over here, we have negative, positive in the second quadrant. We have negative, negative in the third quadrant. And we have positive, negative in the fourth quadrant. All right. Secondly, I'm going to focus on four kinds of moves. Rotating 90, 180, 270, and 360. All right. So if I was in the first quadrant and I rotate 90, that means I'm going to end up in the second quadrant. If I was in the first quadrant and I rotate 180, I'm down to the third quadrant. If I'm in the first quadrant and I rotate 270, I'm down in the fourth quadrant. Hopefully you kind of get the idea with that, okay? Now, there are particular rules that we can follow, and I'm going to highlight these. It says for 90, xy becomes negative yx. For a rotation of 180, xy becomes negative x, negative y. For a rotation of 270, xy becomes y, negative x. And for a rotation of 360, xy becomes xy. xy and xy are the same. Now, you can memorize that. That's one way to do it. I kind of do it a little bit differently. And what I focus on is this. I know that 90 and 270, I'm going to do what I call switch. Now, what I'm switching is I'm switching x and y. All right, so xy becomes yx. And after I do the switch, the next thing I do is I fit. Switch and fit. Now, I fit it into the particular quadrant it's supposed to end up in. All right, so it's kind of tough to describe in words, but hopefully you kind of get the idea as I go through some of these examples. All right, for 180, that's the other one. 180, I think, opposites. All right, really with 180, I mostly focus on just what quadrant is it in, what quadrant does it end up in, make sure that I have the values correct in that. For example, if it ends up in quadrant 3, I know both the values are negative. All right, so let's try a little bit of this. Okay, so the first thing I'm going to do, this one says graph the rotation of 90 about the origin of this figure. I'm going to focus on the points. So I have F is at 0, 3. I have J at 3, 2. I have H at 1, negative 4. And I have G at negative 4, 1. Now I'm going to perform a rotation of 90 degrees. Remember, rotations are counterclockwise. So if I rotate counterclockwise from F 90 degrees, all right, 90 means switch. All right, so I'm going to switch my x and y here. I know that 0, 3 becomes, for F prime, I'm thinking 3, 0. But it has to fit down here on the left side of the x-axis. So it's going to be negative 3, 0. J prime, I switch it. 3, 2 becomes 2, 3. But it has to fit in quadrant 2, so that's negative 2, 3. H prime, I switch it. So that's negative 4, 1. All right? But it has to fit in the first quadrant. That's a rotation of 90, so that would be 4, 1. And then G prime, switch it, 1, 4, and it has to fit in the third quadrant, so I know it's going to be negative 1, negative 4. All right? Kind of replay that a few times and see if it makes sense to you. Now, let's do the same thing, but now a rotation of 180. So I've got F is at 0, 3. Notice I use the same figure each time. J is at 3, 2. H is at 1, negative 4. And G is at negative 4, 1. This time I want to complete a rotation of 180 degrees. So F prime, how do I remember 180? 180 is opposite, opposite. All right? Or I know that 0, 3 is going to go down to the bottom part of the y-axis with 180 degrees. So this would be 0, negative 3. J prime, let's see, 3, 2 is going to come down here to the third quadrant, so it's going to become negative 3, negative 2. H prime is going to rotate from the first quadrant, from the fourth quadrant up to the second quadrant. All right, so that's going to be negative 1, positive 4. Opposite, opposite. G prime is going to go from the second quadrant to the fourth quadrant, so that's going to become 4, negative 1. All right, try one more here. We got F at 0, 3. I've got J at 3, 2. H is at 1, negative 4. And G is at negative 4, 1. Now, I'm going to rotate these 270. 270 means switch. So I know I'm going to switch. But now I've also got to think like I go 3 clicks or 270 degree rotation. All right? If I switch, I'm at 3, 0. 3, 0 is 1, 2, 3 turns. So that makes sense that F prime is at 3, 0. All right? J. If I go 3 turns, I'm going to end up down in quadrant 4. So I got to switch. So this becomes 2, negative 3. All right. H is in quadrant 4. I got to rotate it. It'll end up in quadrant 3. That's a double negative. So I've got H prime is negative 4, negative 1. All right. G is going to end up in the first quadrant. So if I do a switch, I end up with 1, 4. All right. Kind of go through those, all right, and see how that works out. Okay, so the last thing we got to do, it says the coordinates of triangle PRS are as they state. What are the coordinates of the vertices of a rotation of 270 around the origin of that triangle? So I like to do it like this. I just write them out. P is negative 3, 2. R is 2, 5. S is 0, 0. Now, I know 270 is going to move these things 3 clicks, I like to think of it. All right, so I know that negative 3, 2 is in the second quadrant. It's going to rotate 3 quadrants, so it'll end up in the first. I know those are positive, positive, but I also got to remember with a 270 switch. So P prime is going to be at 2, 3. R prime. All right, it's in the first quadrant. It's going to end up in the fourth quadrant when I turn it 270. Fourth quadrant is positive, negative, and I got to switch them. So it's 5, negative 2. S prime. S is at 0, 0. If I rotate it 270 degrees, I'm still at 0, 0. All right? Try one more down here. We're going to rotate it 90. So I'm going to list my coordinates. But they give me this time, they give me V prime. So I've got V prime is at negative 3, 2. I've got W prime is at 5, 1. I've got X prime is at 0, 4. And I've got Y prime is at negative 2, 0. And they want to know where these actually came from when they rotated it 90 degrees. So if they rotate it 90 degrees, that's a counterclockwise move. To go back to the original, to come back here to V, I have to think of it rotating now clockwise. So for example, the point negative 3, 2 is in the second quadrant. I need to move it back to the first quadrant. Because it's 90, I'm going to do a switch. So this is the point 2, 3. I understand these are a little bit tricky. Just keep trying. You got to really think your way through these. Okay, I know that W prime is in the first quadrant. So it came from the fourth quadrant. So I know the fourth quadrant has positive, negative. I switch and I go 1, negative 5 is where it came from. X is on an axis. It's on 0, 4, up on the y-axis. It came from the x-axis and rotated counterclockwise to get there. So I know that X came from 4, 0. And Y is negative 2, 0. That's to the left on the x-axis. So it had to have come from the y-axis, and it would have been up above, so this is the point 0, 2. All right, hope this helps. Keep working on it. Maybe look up some other videos that are online to give you some assistance as well. All right, good luck.